replacing it with the Toisius Pisces through another freestanding riser, which we'll have put in place, and it will be connected to the E.V. Knutson, and that will give us another 20,000 to 25,000 barrels a day of collection. So you can sort of see through this period of time it evolves from the, I'll call it the 50,000 barrels a day that we'll have of collection capability at the end of June. By the middle of July, we'll be up to a maximum of 80,000 barrels a day, but there's a transition period that it ebbs and flows through that period. Now, you'll also notice a few other things on the flow. One of the things that we've mentioned before, but they've now made great progress on, is the subsea dispersant. So at such time as during a hurricane, if we needed to move off location and were unable to shut in the well and we had to go back to letting oil be emitted, it would be dispersed subsea without any vessels there. So this was a bit of a technical challenge, but the teams have made good progress on that, and we'll be putting that in place in the first part of July. And then in terms of the capping valve, I've always told you that we have three options that we're working. That remains. We're starting to favor the flange-to-flange connection. It brings some advantages in terms of its ability to hold back more pressure. In fact, we believe it has the potential to actually hold the full pressure of the well. However, its challenges are around installation, and the teams have been working a lot on all the different tools and equipment that would be required to do that. If all goes according to plan, the good part about that is we'll be collecting a significant amount of oil and gas through the freestanding riser and the Q4000 at the time we're looking to put that valve on, which is a big advantage. So I think what I'll do is stop there. I hope you can see how we continue to evolve, looking to always create more redundancy, more capacity, and basically by the middle of July, we'll be in the range of 60,000 to 80,000 barrels a day of capability, which should give us excess capacity, excess redundancy. If one of the vessels have problems, the others can pick up the slack. So with that, why don't we go to questions?
At this time, if you would like to ask a question, press star, then the number 1 on your telephone keypad. Again, if you would like to ask a question, press star, then the number 1. We will pause for just a moment to compile the Q&A roster. And your first question comes from the line of Joquetta White with Times-Picayune.
Hi, thanks for doing this, Ken. I've always found these very helpful. I have two questions, actually. One, if it appears that you're collecting all or near all of the oil with the LMRP cap, the Q4000, and the Helix at the end of June, is there a chance that you won't change out that LMRP cap for a tighter fitting seal? And then also, if you can describe the other two cap options and how they differ from the one you're favoring at this point, I'd appreciate it.
Okay. Very good question. And I think the key thing is the decision to take off the LMRP cap will be made at that point in time. At that point in time, we'll understand exactly what valve we'll want to use. We'll have worked through all of the details of how it will be installed, etc. So we'll have worked down all the risks. I would expect us to continue to move forward with our plan, and the reason being is we want to create the most capacity with the ability that if a hurricane does come through, we have the ability to disconnect and reconnect as quickly as possible, and that works better with the freestanding risers as well as the different connections we'll be putting in with the Clear Leader and the revisions we're making the Discover Enterprise. I know we're trying to limit to one question here, but I'll go ahead and answer the second. the different valve, we have three options for the capping valve. I explained to you a little bit about the flange-to-flange connection, where I actually have to unbolt the piece that we cut off and then reconnect with a proper seal and rebolt on. The second option is what we call our latching cap, which basically doesn't use the flange. It goes past and, if you can call it, grabs onto a piece on the LMRP, so it kind of holds on from below. I'd really need a diagram to explain how it really works here, but it's a different mechanism. And then the third type was the one I have shown you pictures of before, which was the overshot, which it has it has some good strength to it, but it has a very tight tolerance as it goes by the flange mechanism that's sitting there. And so once again, it has some challenges in terms of installation. So that's why I think we're starting to favor towards the flange-to-flange connection. It just has some advantages, but we continue to think through all of the pros and cons of each of the three as we move forward with them.
And your next question comes from the line of Ray Henry with Associated Press.
Hi, Ken. Good morning. How are you? One of the things I was curious about, and you mentioned a little bit about this, that you think you're going to a bigger system. Do you have any sort of sense about whether or not you're reaching a turning point in your ability to contain this oil? I mean, today from Thad Allen's remarks, you hit 25,000 barrels, and as you said, that is what you believe is hitting the current capacity of Enterprise plus the Evergreen burner. Are you starting to get a little bit more control over this containment?
Well, I was quite encouraged actually when the Q4000 we were able to get it up to its max capacity as quickly as possible. If you watch the ROV footage, it was the most dramatic change. You see a lot more of the LMRP cap than you saw before. As the ROVs look at the plume looks very different. It looks narrower than it used to be. So clearly we made significant progress. I'd like to think that when in less than a couple of weeks, we've got this next piece on, we're going to find ourselves in a good place. But you can tell I'm hesitant to sort of put myself out there and say I know for sure, because I don't actually. But I really feel like we'll be in good shape in a couple of weeks here.
And your next question comes from the line of Ed Crooks with the Financial Times.
Good morning. Thanks for giving us the briefing. Just wanted to check a fact about the ceiling cap. I think there was something I saw in your letter to the Coast Guard when you were describing these arrangements and your plans for raising the capacity of the containment up to 80,000 barrels a day. You talked about the ceiling cap being important for the relief well as well. Well, that's something that, I mean, the implication seemed to be that was something you needed to have into place for the relief well to work properly, and I just wondered if you could explain about that.
Yeah. So when when the relief well enters the existing well, we'll be pumping heavy drilling mud into it, and it will build up inside the wellbore and kill the well. One of the things we'll need to do is we'll want to use the exact right mud weight that will kill the well all the way from the reservoir to the surface of the Gulf of Mexico. So by putting this capping valve in, it allows us to also have a pipe connected to the surface that gives us that additional hydrostatic head of the 5,000 feet, and I think we're going to be using a 14.2 pound per gallon mud, and it just gives us an easier way to make the kill work. It's not absolutely necessary, but since we can do it, it will be a part of the plan.
And your next question comes from the line of Kristen Hayes with Reuters.
That's Reuters. Hi, Ken. Thank you again for having a technical update. I heard you say earlier that the first of the two relief wells is within 200 feet of the Macondo well. Is that right?
Yeah. when we start drilling out, after we set this casing, we'll be within 200 feet. In fact, we believe we're well within 200 feet.